All right, so this would be a typical 2-mark question. There's quite a bit of information in there, so you know, if you probably took out the TAT bit and maybe took out the wins, it might be a 1-mark question. But this would be a typical 2-marker. Remember, you're going to get about 5 2-mark questions on the exam. You're going to get maybe 3 5-markers and 2 4-markers. So obviously that's where most of your marks are. So I'd be suggesting when you do your exam, obviously your main priority is to get those big ones done first. So the priority would be basically do the 5-markers, do the 4-markers, and then maybe go and have a bit of a rest and do the 1 and 2-markers to give yourself a bit of a break in the middle of the exam. You know, pull out your coffee, have your coffee, whatever you're going to do in the middle of your exam, because it is a 3-hour exam. And then maybe go and do the 3-markers, which typically are actually probably a little bit harder. I think the 3-markers, personally, I think the 3-markers are probably harder than the 5-markers. So that's up to you what order you're doing in, but I definitely think, yeah, you've got to do the big ones first because, well, let's face it, you're not going to pass the exam unless you get the 4 and 5 markers out. So that's your priority. Anyway, so this is your typical, you know, find the distance travelled. They're probably going to give you a wind. It's not going to be a forecast wind because you're in flight, so they're actually going to give you your winds, which is generated by your inertial navigation system. And you know, these are fairly typical sorts of winds, and most of the examples you'll find that sort of wind coming from the west, because that is what happens in real life, so that's generally what they'll give you in the actual exam. So all you've really got to do is go, okay, I'm starting at this weight. If you look up page 214, so Sam, you're our guinea pig today. Look up page 214 and tell me what the gross weight would have to be for Mach 0.84. So remembering we're now at Mach 0.8, obviously you can, as you shed off weight, the drag on the aircraft reduces, so you're able to select a higher Mach number. So at some point you're going to burn off enough weight so that you can get down to Mach 0.84. So you look up that gross weight for Mach 0.84. Now, the first thing you do is look up your TAT. So your TAT is minus 12. So if you look up Mach 0.8, actually you'll find that on page 214 the TAT actually is there as well. There's a TAT table in the back, but there's also TAT on the left-hand column there. Yeah. So I think it's minus 17 or something, is it? For Mach 0.8?
Yeah, it's very on.
Yeah, so TAT normally for this situation here would be minus 17. That's from your table. You're minus 12, so obviously you're ISA plus 5. So you're currently ISA plus 5 conditions, and obviously that affects your answers. So when you look at your table on page 214, so I'll put that up here. Page 214 is what we're looking at the moment. That chart, which has got all your weight limits, which is probably the chart you tend to use almost most often in this course. I think it's one of the charts that you will have to look at occasionally. Hopefully you don't have to open that blue book too often, but this is one page you can't really avoid. The limit for that, I think is something like 79 tonnes, if I remember correctly. Is that right, Sam? For Mach 0.84 at ISA plus 5?
Yeah, 79.1.
79.1, so 79, 100. So basically it's saying your gross weight currently is 84 tonnes. You've got to wait till the aircraft burns off whatever it is, nearly 5 tonnes of weight before you can go to this higher Mach number, Mach 0.84. So then it's just a flight, from then it's your standard flight planning sort of scenario. You're saying, okay, what's telling me the distance? Well, the distance is given by integrated tables, so you're going to then have to go to your integrated tables, because remember the integrated tables are going to give you air distance, not ground distance, so you then have to convert your air distance to ground distance. So if you look up, just tell me what page is that on for the home viewers, the Mach 0.8. So we're going to go to Mach 0.8, flight level 310 page.
Page 339 or 3-39.
Yeah, so we're going to page 339, and we're simply looking up that number. By the way, this is my little symbol for integrated table, so it's a little math symbol there, which aviation people are not used to seeing, but that's just my little symbol for integrated table. So if you look at, I'll do that here as well, just to check that we're right. What do you think it is, Sam? 3248. Oh yeah, because it's an exact number, so good thing about, so 3248. Okay, so that's a nautical mile. So in that table, the numbers on, I'll just get that right page again to, would you say 339? Yep. So I'll just, for the home viewers, basically the numbers down the side are tonnes, the number up the top is hundreds of kilos, and the numbers in the middle are all nautical miles. So basically it's converting fuel directly to nautical miles. So we simply go 84 down here, 84, and then 400 column, and it gives us 3248 nautical miles. And we've got to go another, we've got to end up, well basically we've got to end up at 79,100. So just going to keep flying at Mach 0.8 at flight level 310 until the weight reaches 79,100. And in fact that's very simple, because we can now just look up 79,100 and almost magically we get the answer 2729.
Yeah.
And of course the table of course is based on nil wind, so everything in here is a nil wind scenario.
519.
So the difference between those two is just telling you how far you've gone in that interval. So you've travelled 519 air miles and you've burned exactly the right amount of fuel. So notice we didn't have to work out, the great thing is we didn't have to work out time, we didn't have to work out ground speed, we didn't have to work out true airspeed. The only thing we have to do is make sure that we do a correction for our ISA deviation. Remember it's so at the bottom of the page it'll tell you it's 0.9% for every 10 degrees. Now we've already seen that this is a 5 degrees, well ISA plus 5 here. So it's 0.5 times 0.9% of the distance. So basically it'll be 0.5%, it'll be going to be what, 2 point something?
2.3.
Yeah, so we'll call it 2 nautical miles. So as I said, if you forgot to do that, you're still not going to get the wrong, it's not big enough to make the wrong answer, but that's just being pedantic. Generally, what I find is if it's an ISA less than 4 degrees, I don't even worry about it, because it's just not worth doing. So anything less than about 4 degrees, I just ignore it. So this is 5 degrees, so yeah, it's only 2 miles. So the question is, do we add the 2 miles or do we subtract the 2 miles? Now, at least have to have a little think about that. It's ISA plus, it's a hot day, so you're going to be burning slightly more fuel, just like a car does or anything. It always burns more fuel when it's hot. So basically it's saying on a good day, we'd be going 519 miles to burn this amount of fuel. So we're going to only need to go 2 miles less than that. Because we're burning fuel at a slightly higher rate. I think Sean would understand that. Does that make sense, Sean? That if you're burning fuel at a higher rate, you're not going to go as far. So the distance you're travelling is 517 miles. Now that's air distance, of course, not ground distance. So all you've got to do now is convert that air distance to ground, because the question, of course, is asking for distance, which is automatically understood to be ground distance. So we are going to have to do a bit of a wind calculation. So we're going to find our wind component. So our wind component is 60 knots, 295. Yes, and the unfortunate thing about maths and aviation is they never talk to each other. So the answer you get there has always got a negative sign floating around in there that shouldn't be there. But anyway, I think it should be about negative 54 knots. Now, the question is that a headwind or a tailwind? Well, I've put it as a negative, even though in the calculator it comes out as a positive number. it is in fact a headwind because it's from the wind is from 270. As I said, maths and aviation never talk to each other. They always have a conflict about negative signs. So the answer you get has always got a negative sign floating around in there. But given that the people in the home viewers won't be doing it with the scientific calculator anyway, it doesn't really matter. So basically, my rule for that is if these two numbers if they differ by less than 90 degrees, it will always be a headwind. That's my simple way of saying it. If you have to subtract 180 to get it into your cosine table, then it's going to be a tailwind. I think you'll find that the ETAS is nil for that one.
Yeah.
So no ETAS, so it's just negative 54 knots. So we can now do our calculation for ground distance. So, how do we remember that? Well, if you're calculating ground distance, ground speed always goes on top. If you're calculating air distance, TAS always goes on top. Okay, so how do we get the ground speed? Well, we have to look at our TAS first. So the TAS, again, magically is given on page 339. So we've already got that TAS, which is 469. So at the top of the page, it'll tell you what the TAS is, 469. Plus 5, of course, because it's ISA plus 5. Where we write the here is ISA plus 5. So 469 plus 5, 474. So remember, the rule for that is 1 degree. You add 1 degree. For every 1 degree Celsius, you simply add 1 knot, which is a nice rule. It makes it easy. Okay, so that then gives us the ground speed. So we're going to, that's easy. We can do that one, 420. So we've got 54 knots of headwind, so we simply take that off. Air distance is 517. And I'll let you give me that answer, Sam. So of course the ground distance should be, when you've got a headwind, of course, the ground distance should be less, so that you could sort of do that quick calculation in your head to make sure that makes sense. 458 nautical miles. Yep, so that's your plan.